All right. Good morning. Welcome to the third day of the 2021 Python Web Conference. I'm Kim Nguyen at 6 Feet Up, and I am so pleased to have Christian Kasim presenting on Python's NLU library. It sounds like a fabulous tool. One line of code gives us so much functionality. I'm really looking forward to seeing this live coding webinar. What can go wrong with live coding? And Christian is a senior data scientist at John Snow Labs. With that, take it over.
Thank you, Kim. So, Kim already introduced me. I'm a senior data scientist at John Snow Labs, where I created the NLU library. And I am very excited to present to you today at the Python Web Conference 2021, the NLU library, which gives you the power of over 1,000 models in over 200 languages in just one line of code. So to understand this, you might first of all wonder, how does NLU derive all of this power we are promising? This is possible through the amazing Spark NLP library, which focuses on providing the most accurate, the most scalable, and the fastest model out there. And in just 3 years, with weekly, almost 2-week releases, they have already accumulated over 3 million downloads and have become the most used NLP library in the industry, solving real-world problems every day with various amounts of trusted customers. And all of this hard work has been awarded numerous times by the industry. So what will we actually learn and do today? Quite a lot of things. We will first start with spell checking in the real life coding demo. Then we do binary sentiment set classification, and then multi-class emotion classification, followed by really quick parts of speech, and then extracting named entities, so things with names in your text. And then we get unsupervised keyword extraction, followed by question answering, and then translating. And finally, we see how you train your own model that is able to understand 200 languages, even though you only give it one language in the training set. So you train the model on English for, let's say, sentiment, but it can classify all the 100 languages as well. So it will be able to classify French, Urdu, or Turkish as well in the sentiment correctly. Cool. So what is NLU? It gives you all these tools in just one line of code, and it aims to be a truly Pythonic library, integrating effortlessly and seamlessly into the Python ecosystem with libraries like NumPy, pandas, or sklearn. And to truly embrace its Pythonicness, NLP works effortlessly on pandas data frames and gives you pandas data frames also back. And of course, all of this is 100% open source. You are free to contribute new models or code. And of course, it is free to use. So you can make your own company or startup or services from this. So how does this magic work though? How can you gain this power? It's very easy. You just need to know two functions. First, you need to know the NLU.load function. You give it the name of a model. So you just give it a string. And that will return to you a model. This model will have a predict method. In this predict method, you give the data you want to predict on. So a more concrete example, you could say NLU.load emotion, and then you predict I love NLU. And what does it give to you? You get this pretty pandas data frame, which has the confidence for all of the 4 emotions classified. And the emotions are surprise, sadness, joy, and fear. And in this case, it correctly classifies the emotion of joy. And on top of that, you even get the vectorized sentence embeddings from the string. And this is very flexible. So you can just swap the emotion for spell, and now you have a spell checker. And then you say .predict, I like peanut butter and jelly, and you get the tokenized table in this case, but you can also say I want one table. And For every token, you get a spell-checked version. And so like or butter or jelly is spell-checked correctly. And it's so easy. Of course, we provide over 50 classifiers. One of them would be the fake news classifier. You just call en.classify.fake news and then say .predict. And for example, unicorns have been sighted on Mars. And NLU will predict correctly that no, this is fake. And on top of this, one of the most useful features in the industry is the named entity recognition, which we will do in a few seconds. But basically, if you give it a string with named things like Angela Merkel or Germany or American Donald Trump, it will extract these persons, these entities, and it will even assign a label to them. So it knows Angela Merkel or Donald Trump are persons. It knows Germany is location, but American is like the name, like the German guy is also not a location. So it is in this case a MISC, because American is also not a location, but still a thing with a name. So it's a named entity. So you might have heard of all the amazing BERT embeddings, and it was like the image net for NLP. And from this, we got the attention is all you need paper, basically, and the transformer architecture. And on top of that, we grew BERT, Elmo, Albert, and XLNet. So you have all of the BERTology state-of-the-art embeddings in NLU, and you can get all of them in one line of code and create amazing applications in that. And since NLU is truly Pythonic, it works on any typical Pythonic data structure. You can give it strings, you can give it lists of strings, you can give it a pandas data frame, or even a pandas series, so just a column. And if you want to scale to big data, so terabytes of data in a cluster, you can still use Spark data frames, or Ray data frames, or Dask. So, what are all the features NLU provides? NLU provides you a lot of features that other NLP libraries don't give you. For example, there's spell checking, which NLU is the only library, together with Spark NLP, of course. Or the keyword extraction is only available in NLU, or language detection, and many, many other models. And it is steadily growing every day. And here's a quick cheat sheet of all of the easy one-liners you could do. It is as simple as it could be. So we have various amounts of binary sentiment classifiers. Some are general, some are specialized on movies, like the IMDb classifier trained on movie reviews, but we even have some for Twitter. And also we have translators for over 200 languages. All you say is just en.translate to and then the target language. And like you have already seen the spell checking and the NER. And in the second, you will see the amazing YAG algorithm. And on top of that, there are so many classifiers for so many use cases. It is really like a candy box for any programmer. You have emotion classification, spam, fake news, sarcasm, toxic classification, cyberbullying, and much more. And of course, the BERTology things, various text pre-processing methods like lemmatization, normalization, and cleaning, and even part of speech. Cool. So a little bit of background knowledge for one thing I want to show you later is the amazing BERTology embeddings. So if you don't have that much of an NLP background, you might need to know that in NLP, you don't work on the raw text, right? You have the text data and create a numerical representation of every vector. And usually those embeddings are just created for one language. The original BERT was trained on an English data set, so it only made sense to use it for English problems. But smart people at Google created the language agnostic BERT embeddings that were trained on 100 languages at the same time. And it takes away this limitation that, oh, I have one embedding and it only works for one language and you need to make 100 embeddings. No, with Labse, you can train on a French data set and then this model will be able to understand all of these 100 languages you see here. It's really incredible. It's almost magic, but it's actually science. Cool. And after that, we also see today the incredible T5 model, also from Google, which was trained on over 20 problems from the Squad, GLUE, and SuperGLUE data sets, which consists basically of 6 category of problem tasks: text summarization, question answering, translation, sentiment analysis, and a few logical deduction tasks. And also sentence similarity, which can also have a lot of valuable applications. And you can already see here, it's so easy. In one line, you can answer questions, open book questions, and even closed book questions, which we will see in a second more in detail. And finally, there is the very cool Marian NMT model, which basically lets you translate between 200 pairs of languages, also in just one line of code. All you need to know is that you call NLU.load, you put in the start language, and then you say translate to, and then the target language. So for Turkish to English, you say TR, translate to EN. For English to French, you say EN, translate to French, and so on. It could be easier. Cool. And now we get to the fun part. It's demo time. I already kept the demo book warm for us, but in case you want to go with us, so you can just Google, John Snow Labs NLU GitHub, and everything I will be doing today is in the GitHub page. On the GitHub page, when you already are here, you can leave a star, because why not? And then you go to the examples folder, and then the webinars and conferences. And here we have the Python web conference folder with the slides and notebooks, which we will be getting back to in a second. But now I promised you a real-time coding demo, so let's start with it. We basically have a few slots left in the notebook to fill. And I want to show you how easy and fun it is to actually use NLU. The only thing I didn't do, maybe, I think I forgot that. I need to restart my runtime. So let me do that really quick. And after I did that, I also need to configure Java 8 back as standard, I think. So let me just copy this, and then the fun begins. So what you usually would do if you start a fresh notebook, you just install Java 8, PySpark, and Spark NLP. If you copy paste this into your notebook, you have everything ready to go. And then you would configure, if you restarted your notebook, Java 8 back, like I did here. And now you could start the fun. So let's say you want to do spell checking. What you do, you say NLU.load spell, and then predict. I like to live dangerous. And after a couple of seconds, we will get the spell check version. So this might take a few seconds. So we can start with the next thing already. I also, let me just clean also the cells, which I just have forgotten. How do I do that? I just select all cells, and then I click quickly clear all outputs, so you don't see spoilers of what we will be doing. And while this will be loading, I type up the next sentiment example. So let's say you want to do sentiment. So you just say NLU.load sentiment, and then you say dot predict. I love NLU and Python web conference. And then you run that. And after a couple of seconds, today I think the Google Colab notebooks are a little bit slow. So we need to be downloading this for a couple of seconds. But if this is taking too long, I have just for this occasion, I made my backup plan with the pre-compiled notebook. So if this has finished, we get this pretty data frame with the spell check token and the token original token. And we see like is corrected to leak is corrected to like, and dangerous becomes dangerous. And you also would see the deep learning spell check model is being downloaded. Next, let's see. Nice, my notebook is alive again. I got here the spell checking. And now after a second, you see here the sentiment model is being downloaded. And it gives us the prediction. that it is 70% sure that we have a positive sentiment with this sentence. Makes sense, right? And then after this, there's a very useful tool, sometimes, not every time, but it's handy to have. That's the part of speech tool. It classifies, as the name suggests, basically in part of speech, classifies a grammatical label for each token in a sentence. So you can run that. And this model is really tiny and really fast. So this will be done in a couple of seconds. And you can already see what the grammatical labels are. So in case you didn't pay attention in your English class, or it's quite a long time ago, you can see all the labels here. Let's say they are adjectives, they are JJ label, or nouns are NNS, and so on. And after a couple of seconds, for every token in our word, we get this grammatical label and we can match back. And then, for example, we can search for verbs or nouns in our data set. But what's even cooler and more useful is the named entity recognizer. So what do you type? You just type NLU.load NER, and then you type .predict, and then Angela Merkel and Donald Trump don't share many opinions. So this loads a couple of seconds. And so in case you don't know, named entity recognition, it basically finds little pieces in your text that correspond to named things, named entities. And these named entities have different classes. And so one thing you want to do with NLU when you do NER is set output level to chunk. So we run this again. But basically, NER gives you all these classes. And so it says, oh, this piece of text is Harry Potter, that's a person, or that piece New York is a faculty, or it detects organizations like Microsoft, or countries, and so on. And so in this case, it detects Donald Trump and Angela Merkel. Cool. And now we get to the real fun and juicy part. I have prepared for us a little Bitcoin data set full with Bitcoin headlines. And we will see how easy and fun it is to use NLU on a data set. Once you have an actual pandas data frame, then the fun begins. So we do everything we did before. Let's say we want the NER model, and now we apply it to a data set. And the data set is in this TF, and we store the result this time. Oops, in the NER DF. And after a couple of seconds, we will have predicted for the first 1,000 rows the named entities. But we forgot again to set the output level to chunk. So we just cancel this really quickly and load it again. Cool. And so after this is done, what we will basically type is NER.entities.value counts. So we get a column with entities, where all the entities that occur are. And then we count all of our entities. And we take, since there are over 100, a few thousand entities, we just want the first 50. And of these, for these, we say .plot .bar. And let's say bar h, because that's nicer. And we will need a fixed size, that's 2020. And if this is not done in a few seconds, we just go to the backup. But it should be done any second. Any second. Otherwise, okay, let's cheat real quickly. So this is the Bitcoin part, right? Where we just we load the data set, and we get a nice pandas data frame with entities, right? So we see the first data set. In the first sentence, there's the entity China, and the other, and it's a GPE. The other one has date. The other one has Australian, Chinese, and we get all the confidences. Cool. And from this, we can easily, what I was just typing, is it done now? Yes, nice. Now we can actually go back to the notebook. We can run this command, and what we get is the distribution of named entities. So we see, first, the named entity first is occurring a lot, and that makes sense because that is a numerical entity. After that, we have US, and China, and Bitcoin, Chinese, BTC, Indian, and so on. So in just one line of code, we already know what's going on in the crypto news land. Very cool. But now, remember, each of these entities has a label. And so instead of having all of these different entities, we can filter by label, right? And just look at a specific label. And how do we do that? It's pretty easy. We say any RDF dot entities classes, I think. Let's look. What was the column name again? Entities class. And so we check, let's say we want all the entities that are person. So we just say this column should be person. And then we should run the same code. And yes, it runs smoothly. Very nice. And now we have all the named entities which have the label person. So now we know, aha, Ross Ulbricht, this is some guy. It occurs 3 times in the first 1,000 rows. That already is quite a lot. And of course, you can run it much more, but then you also need a bit more time. Then there's also Richard Branson, Bobby Lee, Peter Thiel, and so on. So lots of people, lots of insight. But you can also, right, there are 20 classes, almost 19 classes. We can also say, I want the organizations. And now we filter by organization, and now we have Bitcoin, BTC, Senate, some Fin company, I guess, eBay, ASIC, some other company. Ooh, and the FDI, watch out, guys. And more, and Coinbase, and so on. And so it's pretty cool. And, right, you can take any of these classes we have here. Let's say I want to filter by product, right? Oops. Then I just take this string basically, and I just type product over here. Product. And now it's only those with product label. And so it's not talking a lot about black market reloaded and some Buttercoin and so on. So that's very interesting. Cool. So that was the NER part. But another tool we have to extract data, key or information from your data set is the Yake algorithm. It's one of my favorite algorithms in NLU because it's so fast and also it has no weights. So you are downloading nothing because it's completely unsupervised. It doesn't have any training data. You just start it and it crunches you incredible keywords because it uses n-grams and lots of statistical theory to extract relevant keywords. So in this case, you get the keywords update, China, and China lead. Or here, evangelize, Bitcoin, evangelize about, and of course, the confidences. And what can we do now? Just like with the named entity distributions, we can now say Yake df, and we get the named entity, the keyword distribution now. We say Yake df dot explode, and we say keywords classes. So we take that column, and then we say again that column dot plot dot then we say dot value counts, get the first 50, and then plot bar h because that's nice, and then a fixed size 2020, and then we run that. I hope we didn't mistype, and we didn't. Nice. So we see all the keywords, and for example, we have the Bitcoin Z, and that now is arguable. Oh, why is this separate? And in another webinar and notebook, I showed how you can fix that. And if you want to know how, just go to the examples in GitHub and check that out. But we don't cover that today because we're short on time. But there we can see already we get different insight and different information from the data set. And if you have a bunch of text data and you calculate that, you know so much about your text data. So it's very powerful. Cool. Now, the last part, or not the last, but we're getting there, is the sentiment distribution. That's pretty easy. And actually, we're not even halfway done. But, so, cool. So, how do we get the sentiment for every row in our data set? It's very easy. We say NLU.load sentiment, and then say we predict the DF and save that. And then just as before, right, we have now the sentiment column with the predictions and the confidences. We paste this and then say we take the class .value counts .plot .bar, and now we have the distribution of sentiment. And now let's say now we want the emotional distribution, right? That is multi-class. And what do you change? I think you see the pattern now slowly. You just change the NLU reference, you change this variable name, and then you change this, and you're done. Boom. So this works with any of the 50 or more than 50 classifiers we have in NLU, and you can easily get a lot of insight and power from your data like this. With the emotion distribution, sentiment distribution, NER distribution, Yake distribution, and much more. Cool. So this was it for the data exploration part, and also for the live coding part, because the rest is taking a bit too long to run. So I still have more code prepared for us, and it is in a notebook, but we will just sadly not be running it because we are a bit short on time. But basically what you see here is, this is the emotion data frame, right? We would have run here emotion, and we get the emotion confidences and the emotion column with all the emotions, and then we can plot the distribution and see 50-50 between fear and joy, a bit of surprise, a bit of sadness. And at this point, you would restart your kernel and have some fun with Google's T5 and start with the question answering. And for question answering, you need to know there are basically two types of questions. The closed book questions, which basically are the type of question where you can only use the knowledge stored in your brain, in your weights. And how does T5 do that? Or how do you do that with NLU? You just say NLU.load en.t5, and then you just give it the question. And that's it. So you ask, who's president of Nigeria? And it will tell you Muhammad Buhari. And if you Google, that's correct. If you ask, what's the most common language in India? It tells you Hindi. If you want to know what is the capital of Germany, it will tell you Berlin. And I can confirm you that's correct. And after that, now that was the closed open book questions. That was the easy part, or the still cool part, but now it's the even more interesting part, the open book questions. So in open book questions, you give the model some extra context and then the question. So you ask the model, based on this context, what is the right answer? So the simple example here is, Peter's last week was terrible. He had an accident and broke his leg while skiing. So we have two questions. Why was his week so bad? And how did he break his leg? And in here, we just combine question plus context. We just concatenate the string for both questions. And NLU correctly figures out for the why was this week so bad that he had an accident and broke his leg. That's the correct answer. And how did Peter broke his leg? Skiing. So that's very smart, T5. And if you want to extend this, I took here a little news article about Alibaba's founder, Jack Ma, and his reappearance in the Zoom meeting. And you can skim it really quickly. But basically, you can give T5 an article or a knowledge database, lots of information that you don't even want to read, and then ask T5 about that article. So in this case, we asked T5, who's Jack Ma? Who's the founder of Jack Ma? The founder of Alibaba? When did Jack Ma appear? And let's check out the answers. So Jack Ma is the founder of Alibaba, right? Who's the founder of Alibaba? T5 tells you Jack Ma. When did Jack Ma reappear? Wednesday. How did the stocks react? They surged by 5%. That's correct. Whom did he meet? Some teachers. And who did he hide from? Chinese regulators. So T5 correctly understands all of that. Amazing. And so there are multiple tasks you can do with T5. They are all available in NLU. Some of them are not that useful, but many of them are. We sadly cannot cover them all, but I encourage you, check them out. And basically, here's the last example for text summarization. So you have here a giant text about Bitcoin, and then you just say summarize, and then predict it. And then you see the summarized, the original version is 1,300 characters long. And the summarized is 350 characters long. And if you skim this text and up here, maybe after the lecture, because we're a bit short, you see the semantic meaning is same, because it basically says MasterCard said on Wednesday, it supports cryptocurrency. Wow, that was a big headline, and some other stuff, but that was the important part. Very good, T5. It's pretty powerful. And so finally, the translation part, how do you do that? You just need to know the start language, translate to, and the target language. So translate to German, you give it a data frame, and now you have a German column. Let's say Bitcoin Survival, Bitcoin Überleben. massive Bitcoin sale going on, massives Bitcoin verkaufen geht weiter, and so on. So that also works for Chinese and also Hindi and over 200 languages. So it's very incredible. And now just a quick peek at the training. I explained to you the labs embeddings that make your model so powerful. And how do you do that? It's very easy. You need a data set with text and a label. It can be binary or multi-label. And then you just say NLU.load. You say the embeddings you want, because there are also other embeddings. And then train.sentiment. And then you run the pipeline on the data set. And then you get metrics. And you can check for yourself later on. So this was a French data set, right? But it properly classifies English, German, Vietnamese, Afrikaans, all of these Japanese languages. It's incredible. So to wrap up, I encourage you, definitely check out the Models Hub, which is basically, let's go down here again, all the way, nice. The Models Hub and the NLU namespace. So the Models Hub, you see all the models available. And NLU is basically like a searching tool for NLU, which is maybe down right now or not properly working. Crap, but usually you can go to here and search for all the models. Okay, now it loaded a bit slow. Cool, so you can click on a task and you can say, oh, I want to see all the text classifiers. And then you say go, and you see, oh, there are so many classifiers. And all other tasks, question answering, summarization, embeddings, and so on and so on. You can even sort by language. And it's so much that we have. So that's why we created the Models Hub. So you can see all the value we provide. And finally, there's the NLU namespace, where you even can see all the references as a table. And last thing I wanted to point out about the Models Hub is when you click on some of these models, let's say this one, then you have documentation here and also code on how to load it from NLU. So you can just copy paste this and run it and get question classifier. Cool. And so last page I just want to show you is just the NLU website. When you go to the website, you can scroll down and see all the things you can do here. You say, I want spam classification, click, go there, and then you have it there. You copy, paste, and then you can run it and have spam classification. And all the other tools. So there are lots of features. And if you want to get started, you just click getting started. And also you click on the Slack and join us there if you have questions and want to give us feedback. And here's everything you need to install NLU and call it. You just copy paste this and run it. Cool. So as a reminder, everything we did today is on GitHub. And that wraps up the tutorial part, the demo part. And I'm just wrapping up with the last few slides. So what does NLU include? It's 100% open source. You can use it completely for free. Over 1,000 models, over 100 embeddings, over 50 word embeddings, 50 sentence embeddings, multilingual. We have over 50 classifiers, 200 languages. We have dependency parsing, labeled and unlabeled. You didn't see that today, but it's in there. Spell checking, everything in one line of code. Keyword extraction, a lot of text processing like text cleaning, lemmatization, or stemming. You have summarization, answer different types of questions, all the squat and glue and super glue problems. You can train classifiers for various problems, and they all achieve the highest accuracies with these embeddings you use. You can crack any state of the art easily in most data sets. You have aspect NER and aspect sentiment NER and even intent classification, which we also didn't cover, but you can check it out. Cool. So here's the quick cheat sheet again. Everything, the coolest features, all in one line. And over 200 languages. Also, there's incredible, you can do sentence similarity and do crazy cool similarity matrices between sentences. And there's one good article about Stack Overflow questions and how we compare them and find similar questions. And by this, we find answers to questions. And then also test-me visualizations. So you can visualize the embeddings of your data. And then you see, oh, all my text. So you can visualize your text cluster and see, oh, my text is forming semantic clusters. Very impressive, very cool. So here are many more resources. You should join our Slack, check out our website, the GitHub, and all the tutorials. There are many out there. And also, let me just show you on the GitHub, we have really an incredible amount of tutorials in the examples folder, in the collab folder, and there's so many things you can try out, and especially also the training section. We have tons of training examples. Cool. So I thank you very much for your attention. And I hope you enjoyed this talk, you learned a lot, and you feel your power level has increased today. And I am happy to receive any questions.